Hi there, welcome to Mini Math Lessons. So today we're looking at a lesson that is on music, musical pitch, and using the Hertz frequency for sound waves and looking at octaves as you move up a keyboard. So there's a little bit of a descriptor here at the beginning, and I'm using ClassPad.net. So this is an activity that was adapted from the Fostering Mathematical Thinking Through Music resource book that Casio has for their hardware, their graphing calculators, and it's been converted into an activity for ClassPad.net. If you're not familiar with ClassPad.net, it's a free, always free, dynamic math software. You can just start exploring. I've shared the activity below as a URL, and so you don't have to have an account. You can actually just do the URL and play along. If you want to save it, create an account. I highly suggest creating an account because then you can create your own things and find lots of activities. Let's go back to the activity. So this activity is talking about the pitch of a note. So when you're tuning a piano, it's based on the pitch A that has 440 hertz, a frequency. It's the vibrations per second. And so based on that, each octave doubles the frequency. So the students are going to first collect some data, create the table. So they have to kind of use this information to figure out what these numbers are. So if the 0 is our starting pitch at 440, what would it be if I went up one octave? Well, it says it doubles every octave, so I should be able to do this in my head, but if I double that, my next one is 880. But what happens when I go to the second one? Well, I could be calculating these by hand, and so we know that we start with 440, and the first time we multiply by 2, right? Not x, 2. And if we're going to go to the second one, well, we're going to multiply by 2 again. So each octave is doubling, so I'm going to have to multiply by 2 again, and I'm going to get for this second one a much larger frequency pitch, right? And so what we're hoping they do, well, what happens when I go down? So I'm going down an octave now. So it still starts at 440, but instead of doubling, I'm sort of halving, which is 2 to the negative, right? So we could say -1. And so what we're hoping they start to recognize is that these octaves represent exponents. And so let's put this one up here, 220. So maybe I could use my connection here between my table and my calculation to just fill in the rest of the table all at once. If I understand that frequency, so notice I'm using the label of the column, and I'm going to make a function. And I know that it starts with 440, and it's going to be multiplied by some power of 2. And where is that power of 2 coming from? Well, to get this one, my power of 2 came from the octave. And to get this one, this was really 2 squared, that came from the octave. So instead of raising it to a specific number, I can raise it to the power of and use the word octave, and I should fill in the rest of my table. And there you'll see it. So we're trying to not only get them to understand the patterns and do the calculations, but also to see how the exponents are coming from the octaves, and that determines your frequency. So they've done this. The next thing they're asked to do as we scroll down, I'm just going to go through this pretty quickly, is to take this information and look at it in a frequency table. Not frequency table, a scatter plot. So I selected the columns, and now I'm going to graph and scatter plot. And so now I should see a scatter plot of my information. And since I was using exponents, it makes sense that this looks not linear, but it looks, like a curve, an exponential curve. So then they talk about that, and they try to use this pattern to come up with their own formula that would fit this graph, right? So let's say they come up with the formula y equals 440 times 2x. Is that what we're doing here? And then let's see if that actually graphs. I keep using the keyboard instead of and then I can use this template right here if I want to So let's see if that works. And it seems to fit pretty well, right? But they could verify it now. And so this is one of the things they're asked to do. Can you make that, verify it with a regression? So let's hit a regression. And I'm thinking it's probably exponential, right? So let's see if the exponential works. And it does fit right on top of it. So then, but what if it didn't? They could test theirs. So now we're looking at, here's our regression. You know, how does that help us? Here's our regression right there. What's B? What does all of this mean? So it's kind of just helping them understand that the music relationship in piano, keyboards and stuff, the pitch, the frequency is exponential, that there is a relationship between them, and that's where they're going. So then they're asked to kind of explain and compare. So that's the activity. So they're doing a lot of different type of math here. They're doing tables, they're doing scatter plots, they're doing regressions, they're doing formulas. So a really nice exploration of music and math connections.